So in this case, guys, we are simply going to consider our laws of exponents as we had these laws of exponents in our grade 8 mathematics. So what I want you to do is to go through those notes that you had in your grade 8 as they are, and also the videos that we had, guys. If you were part of our mathematics in grade 8, then that means you already have the notes that I listed before about our exponents. Remember, your exponents, guys, you're simply working with the condition of a certain number raised to a certain exponent, where a is simply representing the base of a logarithm, the one that we're going to talk about later on in your mathematics. Then we consider m as our exponent. So that is the major part, guys, that you're going to actually need to understand. And in the simplification, definitely, it's all about the laws. It's all about the laws that you are going to use. So every simplification, no matter given a question, think about the laws. So which laws exactly are we going to have? So we are going to have all the laws that we considered in our grade 8 mathematics. So I'm just going to quickly write them. So remember, we said when you're multiplying numbers that are of the same basis, a to the exponent of m times a to the exponent of n. These are same bases that you're multiplying. You simply add the exponents. All right. So remember your laws, we said we're going to add these exponents. Number two, when it is a division, a to the exponent of m divided to a to the exponent of n, we are going to subtract. For a division, you subtract these exponents. So it's m minus n. So this is a law. A law, you're supposed to know how to use this law. So like I said, guys, this is just like a recap of your grade 8. So I'm just going to quickly list all the laws. Then we're going to have an exponent raised to another exponent, a to the exponent of m raised to another exponent. You multiply these exponents together. So it's a to the exponent of mn, a to the exponent of m times n. So m times n gives us mn. All right, so that is an exponent raised to another exponent. We can have a condition where there are two terms or two numbers that are being raised to one exponent, like this, a times t raised to the exponent of n. This condition, we said everything will be raised to the given exponent. So we are going to have a raised to the exponent of n. Also, the t is going to be raised to the exponent of n. Remember, that's a product here that we are having. That's a times t. So you're going to have the a raised to the exponent of n, the t also raised to the exponent of n. And law number 5, we said any number when raised to the exponent of 0 is going to give us a 1. But remember here, there are conditions that you need to put into consideration. So that is why I was saying, please do make sure you go through the videos of grade 8 exponents so that you just have a recap on this part, because it is going to be important, guys, in your simplification. So you had these laws, guys. As you had them, you're going to apply them. The only part now that you're going to add on the laws is this one, that if a number is being raised to a negative exponent, a, when raised to the exponent of a negative, take note, it's a negative there. We can remove this negative exponent that we are seeing here. We can remove this negative here so that it remains as a positive. So how do we remove this? The moment we remove this, we are going to have it as 1 over. So this 1 over is to remove this negative. It's no longer there. So if the negative is no longer there, what does it mean? It is now a to the exponent of m. So here we are going to have the negative no longer there. It is no longer there. The moment you write this 1 over. So this is the part now that you must work mostly on your grade 9. Like I said, this is your grade 8 recap. Then your grade 9, you're going to introduce and some of the equations of our exponents. We're going to talk about that. So whenever you have a negative exponent, when 2 is raised to the exponent of a negative 3, like this, there's a negative exponent. From this law, how do you remove the negative? It is equal to 1 over. To remove this exponent, you write as 1 over like this. The moment you write as 1 over like this, the negative is no longer there. So it will be 2 to the exponent of positive 3. 1 over 2 to the exponent of positive 3. So that's 1 over what? 1 over 8. Remember, 2 to the exponent of 3, 2 times 2 times 2. You're multiplying 2 3 times. That is the condition. You're multiplying 2 3 times. So that will give you 1 over 8, or you can simply use your calculator to verify this. That's the condition. So you must be careful in your simplification when given a negative exponent, because you might be given something like this, 3x to the exponent of negative 3. Mostly, guys, you tend to make mistakes when you are given to simplify something like this. It's true that I said to remove a negative, you remove it as 1 over. But take note, what is being raised to the exponent of a negative here is this x. It is the part of x, not 3. Remember, if I write AB, it simply means A times B. So using this concept, we can simply see that this part is the same as 3 times this part here. It's on its own, the one that is carrying a negative. So it's 3 times x to the exponent of negative 3. You can separate it. 3 is a number on its own. This one on its own. So we can simplify 3 times. How do you remove the negative? Remember here, we said it's 1 over and it carries a positive. So it will be 1 over. We remove this negative and it will be what? Positive 3. So this is where you are. Can you leave your answer like this? Remember our numbers, whole numbers. If a number is written 3, it is the same as 3 over 1, every whole number. Even terms like x is same as x over 1, x over 1. Every number, 10 is same as 10 over 1. Dividing by 1 does not affect. 10 divided by 1, simply 10. So this 3 that we are seeing, it is same as 3 over 1, so that you can properly see that your multiplication here, the 3 is on top, not here. It is not 1 over 3, no. The 3 is on top. So it's going to be 3 times 1. 3 times 1. Remember multiplication, guys. You multiply numerator to the numerator. So that's 3 over 1 times x to the exponent of 3. That is x to the exponent of 3. The denominator to the denominator. So this is the idea that you must have, that you must use in your simplification. No, these typical questions, it's not about just you see a negative, then you write 1 over. Yes, there are conditions that everything is going to be affected. Let's say it was like this, 3x to the exponent like this. Let's say it is given as -1 or -3 like that. The bracket shows us that every term is being affected. Let's go back to our law, which is here on law number 4. If you consider here, the product a times t raised to a certain exponent, a and t. Take note, these two terms, this term and this term, are the ones that we are seeing here, this term and this term, raised to the same exponent that was the a to the exponent of n. This is t to the exponent of n. So in our case, it is the same thing. Meaning we can simplify this as what? We can simplify this as 3 on its own, because this is like there's a times here, there's a product, it's on its own. So 3 will be raised this time to the -3. Also, this x is going to be raised to the negative 3, to the exponent of negative 3, just like that. Each term. Then we can use our law. So remember, your law is saying what? Remove the negative. How do you remove the negative? 1 over that. So this part of 3, you work it on its own. You simplify that part on its own. So it will be 1 over like this. 3 to the exponent of 3. You have removed the negative. Times, you do the same thing on this x. You remove this negative. So it's 1 over x to the exponent of 3. So from there, guys, we can multiply just like the previous case. The numerator affects the numerator, the denominator to the denominator. We know that 3 to the exponent of 3 is 27. If you, okay, you can just simplify. Let's write 1 over 27, 3 times 3 times 3. 3 times 3, that is 9. Then we're going to multiply to the what? To the 3 that is remaining, which is going to give us a 27, all right? Times 1 over x to the exponent of 3. So since we have got a single number there, let us multiply, guys, numerator to the numerator. 1 times 1, that is 1 over what? 27 times x to the exponent of 3. That's 27 x to the exponent of 3, just like that. Everything was affected by negative 3 because of the bracket. The bracket, once you see this bracket, every part will be affected by the exponent that you are given. This is the condition of our question. So I want you to go through these laws and also apply this one that we referred, the one that we have in our grade 9, but these ones also use them. As you can see, we also applied this part. So it's a continuation. Anything that you had here is going to be a continuation there. So let us just look into questions which are going to use like all of the laws that we just gathered. We're just going to look into typical questions, how these questions might be given as. So the questions might be given, simplify. So these are just typical examples that we're going to look into. We might be given to simplify the following expressions. The following expressions. All right, so simplify the following expressions, leaving your answer. So you'll be given an instruction, leaving your answers, leaving your answers. All right, leaving your answers with positive exponents, with positive exponents. So what they simply trying to say is everything must be positive. We are not supposed to have negative. So remember, there is a law that we can use to remove that negative. So we are not worried if we see a negative in our final answers. All right, so we are going to simply change and put it to be a positive by using this concept. So let's gather questions which can use all of the laws that we have mentioned here, guys, that we are simply going to have. All right, number 1, let us say we are given to simplify 3x to the exponent of 4, y to the exponent of 5 times negative 4x to the exponent of 3, y to the exponent of 2, like this. All right. So which law can we use? It's a product. So we are going to use the product, this one, that if the bases are the same, we add the exponents. So what you do is that you start with the numbers, guys, on their own. In fact, the signs that are affecting the numbers. Here the plus, here there's a what? A minus. So you're going to multiply those numbers on their own, okay, considering or using the signs. So this is plus 3 times 4. Plus 3 times minus 4. I mean, this one, the minus 4. So plus and minus, that's a minus. 3 times 4, that's a 12. So that is we've got what? Minus 12. On the multiplication of numbers, do not worry. Even if you do not know this, use your calculator, guys. All right? Remember, you've got a calculator also in exam. So that is it. This is about the numbers. Then we move on to the part of x here. There is x. Look at this part. There is x here. To the exponent of 4. There is also x here to the exponent of 3. Once you see this, guys, it is the same base. Same base, but what is happening? Under a multiplication, remember your sign here, the sign is very, very important. That is, what is it under the sign? It is under a multiplication. So we are saying if we are multiplying same bases like this, we are going to add their exponents. So you take this one of x, all right? What is its exponent? It is what? It is 4. You add a plus. What are we adding? This one of x, it is raised to the exponent of what? Of 3. We add its exponent there, which is 3. Okay? These are same. We do the same thing. Do we have anything that is the same? Yes, we've got the part of y here. This is y to the exponent of 5. This is y to the exponent of 2. They are the same basis of y. Same basis. So you take that y as it is, you write it as it is. So this is y as it is. What is the first exponent? It is 5. Remember, you are multiplying. So you are going to add the other exponent, which is what? Which is 2. So that's the condition. You are multiplying, you add the exponents. So let us simplify and see what you're going to have. So this is going to be minus 12 x to the exponent of 4 plus 3, that is 7. All right, this is y to the exponent of 5 plus 2, which is 7. So this is what you're going to have. And these answers, the answer that we have, it has positive exponents. If there is a negative, you must remove that negative. All right? So this is direct, guys. You just have to apply this law like that. You're done. You're done. This is your simplification, your grade 8, like I was saying before. All right, so what you're going to do if you are actually watching this video, because I'm just going to work out our exponents, all of them in this video. So you can actually pause, you can indicate the time on the video where you stopped so that you can come back and continue from there until you're done with the whole topic of exponents. Then you do the question papers, all right? So I'm just going to do this part all in one video. So please just make sure you go through a lot of questions after this. Where there are questions, remember your comment section, guys, is there. Communicate so that I can do that question. You can send it to my WhatsApp so that I can work out that question. It will be of your benefit. All right, so that is it, guys. That is the condition. All right, let's consider another example. 2x to the exponent of -1 times 3x, like this. You are multiplying. What are we going to do? Still under the same part, guys, of a multiplication. All right. So we start with the numbers 3 and what? These 2 and 3. Let's multiply these together. That was going to be 2 times 3, which is 6. Then the part of x, this one, there is x, there's also another x. What is it that you must do on this x and this x? You have to add their exponents because you are multiplying. Remember, here the sign is multiplication. So the question is supposed to be, what is the exponent here on this x? If the exponent is not given on a number or on a term, it means that's a 1. 2 is same as 2 to the exponent of 1. X is same as x to the exponent of what? 1. So when you see this x, the exponent is there. There is a 1 here. So this is it, guys. You're going to add your exponents because you're what? You are multiplying same bases. So that's x. We add our exponents. So that's -1 plus a 1, like this. All right. So what are we going to have at the end? 6x to the exponent of -1 plus 1. That's a 0. Can we leave our answer like this? While there is a law which tells us that any number when raised to the exponent of 0 is 1. No, we have to simplify. Remember what I said, guys. This one is simply what is raised to the exponent of 0. It's not 6. It's x. It's different from this one. It is different from this. Here, the whole bracket is raised to the exponent of 0, so it gives us 1. It is just like 6 raised to the exponent of 0 times x raised to the exponent of 0, like this. So it will be 1 times 1, which is 1. But in this case of ours, it is not 6 which is raised to the exponent of 0 here. It is the x here, the x. So if you do not want any confusion here, separate them this way. Like I said before, 6 times here, x to the exponent of 0, so that you properly see what you're working with. So that is your case. So this is what? 6 times what? Any number to the exponent of 0 is what? It's 1. Very true that it is 1. So we can multiply now. 6 times 1 is what? It's 6. That is the case. So please be very, very careful. Do not rush when you're answering your questions. Look into the question properly. How are you given your questions? All right, another example. I don't know now, it's number what? Maybe number 3 or number 4. All right, let's just consider the part of a division. And let's just consider, guys, we're just going to combine all the laws. Simplify -4, p to the exponent of -4, q to the exponent of 3, everything over -3. This is p to the exponent of -3. Then this is q to the exponent of -4. All right, so according to our laws, guys, let's consider what can we use here. A division. All right, take note this here, a division that we are having on law number 2. It is the same thing, guys. A division is like this: a to the exponent of m over a to the exponent of n. It is the same thing. That's a division, all right? So let's start with the numbers. This is what we have. We're gonna start with the numbers. So this is equal to, we divide these numbers on their own, -4 and -3. So take note, guys, definitely the negative was gonna cancel. 4 over 3, we cannot divide this, just gonna remain as what? 4 over 3. Just leave it like that. Move on to the part of p. These are the numbers, guys, remember. So leave this part as it is, all right? You move on to this part of p here as it is, this one. This is the part of what? Of p. So it's on its own. Multiply like this to say I'm now on what? On p. I'm separating this. But it is under what? This one. It is under a division. This is a division, this one. P to the exponent of -4 divided to p to the exponent of -3. So what is it that you're going to do under a division of the same base? The base is the same. P, this is P. You are dividing. So let's go back to our law. For a division, we saw that we are going to subtract the exponents, m minus n, under the same base. The base is not going to change. It is going to remain as it is. You simply have to subtract. So this is what you are going to do. The exponent, which is on top, minus this one, which is below. That is m minus n. M minus n. So what is on top on our question is what? -4. So it's p to the exponent of -4. We are going to subtract, guys. What are we subtracting? Take a closer look. Take a closer look. What are we subtracting? It is carrying a negative. So it is what? -3. Open a bracket. Remember your operation of numbers. Minus, you are subtracting a negative. You are subtracting a negative number. So you must put what? A bracket to show that negative is going to affect there. So it will be the minus this one. This one is for our laws of exponents that we are dividing the same base, this one. It is of the laws of exponents, this one that we see here. But this minus that is here on 3, it is the sign of the number. It is carrying its own negative. So do not neglect that. It is carrying its negative. It is having its own negative. So you do that on the on this part of Q. You're gonna do the same thing on this Q, same basis. So you're gonna subtract, just like our previous question, our previous case of P. So we're gonna multiply to Q to the exponent of what? Take note, on top it is raised to the exponent of 3. So we're gonna subtract What are we subtracting? The exponent, this one in the denominator, which is what? A negative 4. Negative, negative, just like the previous case. This negative is of the law division. Same basis we subtract. But this negative is for what? The exponent on its own, it is carrying a negative. So do not confuse between these two. All right. So we have applied our laws, guys. Let's simplify from there. That was going to remain as 4/3 times. We simplify. So this is you guys and your numbers. Remember, negative, negative, that's a positive. So it's -4 plus 3. -4 plus 3, which is what? -1. So it was going to be P to the exponent of -1 times, we do the same thing on a Q, negative to a negative, that was going to be a positive. So it's 3 plus 4. All right, so you're going to add 3 plus what? 4, which is a 7. So that's Q to the exponent of 7. Remembering our question, our answers are supposed to be what? Positive exponents. Positive. But in our case, look at this one. There is what? A negative. So we go back to our law number 6. Remember? Sorry for that. Let's go back to our law number 6 here, which is saying when raised to a negative, we remove that by what? 1 over that without a negative this time. So it will carry a positive. So we're going to use that law 1 over. So that will be 4/3 times this one, 1 over P to the exponent of 1. It's now a positive. But guys, what is 1 over P to the exponent of 1? It's simply P. Any number raised to the exponent of 1, guys, remains like that. Even the letters, the variables, all right? So the Q is already raised to the exponent of a positive. This 7 is positive. So it is going to remain as it is with a positive exponent, all right? So this is over 1, all right? Remember, guys, what I was explaining, that every number, every whole term is same as over 1. So this Q to the exponent of 7, since we are under multiplication, we can write it as over 1, so that we can simply multiply the numerators together. There's nothing that we can do now. There is no law to be used. We do not have the part of P and another P. They are different. These two cannot be combined. So just multiply as normal your numbers. You multiply the numerators together. 4 times 1 times Q to the exponent of 7. So that's 4Q to the exponent of 7 over what? 3 times P times 1. So that was going to give us what? 3P. 3 times 1 is 3. So it's going to remain as what? 3P. Just like that. These are positive exponents that we have on our final answer. Nothing is having a negative. So that is it, guys. With this, you need to work out as many questions. Like I said, I'm not gonna, guys, do as much. Just go through your questions, your textbooks. Try to revise as much questions as you can. Where there are questions, let's communicate so that we can work on those questions together. So that is how the questions are mostly given as. So I'm just going to do last question, then we move on to another part so that we can be able to finish up. All right, another question. On these examples on how to simplify, we might be given, let's say, -5 m to the exponent of -3 to the exponent of 2. All right, take a closer look from our laws. Remember, this law number 4, everything must be raised to the exponent which is outside. So in our case, these numbers and terms must be raised to the exponent of what? Of 2. So this is -5. So we are going to take it as what? -5 raised to the exponent of what? Of 2. These are two terms. Just separate them this way. -5 on its own. Then this part of m, it's this one, it's a single term like this one. It's a single term like this with its exponent. It must move with its exponent. So that's times m to the exponent of minus 3, but raised to the exponent of what? Of 2. Remember, we are separating this to the exponent of 2. This one to the exponent of 2. And also this to the exponent of 2, which is this one to the exponent of 2. This is where we are. Be very careful. Very, very careful. So minus 5 to the exponent of 2 means what? Minus 5 times minus 5. Minus times minus, that's a positive. 5 times 5, that's 25. So that was going to give us positive 25. All right. Let us move on to this other part of m. Take note. The m is raised to the exponent of negative 3 and also raised to the exponent of 2. Which law can we use? Let's consider law number 3. An exponent to an exponent, I said you simply multiply them. M raised to the exponent of n, like that. It's m and n, so you multiply them together. Exponent and another exponent, multiply this. So this is our case of our quotient, guys. Do not worry about this one. To see this, simply multiply these two. You multiply them. So that is what? M to the exponent of minus 3 times 2, which is minus 6. Minus 3 times 2. But the question is this in simplest form? No, 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 no. Because of what? The negative exponent. We are told our answers are supposed to be what? Positive exponents. So we are supposed to get rid of that negative using what? Law 6. A negative can be removed 1 over. Remember this? So that's 25 times 1 over m to the exponent of 6. 25 is a whole number. So as a fraction, 25 over 1. I explained this part. So that we can multiply the numerators together, the denominators together. So it's 25 times 1, which is 25 over 1 times m to the exponent of 6. That's m to the exponent of 6, like that. Can we simplify from there? No. Everything is having what? Positive exponents. So guys, we can just leave it like that. So I want you to go through many questions, do as many revisions. Guys, please do as many questions. Mathematics, it's all about what? Calculations. So that is it, guys. Let us move on to another part, which is the last section in your syllabus, guys, as you are considering your mathematics grade 9 working with exponents. Once you know these laws, you are done. Okay? Once you know these laws, guys, you are done. Then you need to solve what are called exponential equations. Okay? You know equation. Okay, let me start by equation. Once I say equation, we talked about equations, guys. It's not the first time from our grade 8. 2x plus 7 is equal to 8. We solve our equation, take this to the other side. So 2x is equal to 8 minus 7. 2x is equal to 1. So divide by 2, we obtain the value of x because it's a what? It's a product here. So x is equal to what? 1 over 2. You were solving equations before. So you saw that an equation, it's a statement where we have an equal sign. 2x is equal, the left-hand side is equal to something. There is something that you compare. The left-hand side, you compare to the right-hand side. There is a comparison between two things. It's not like a they were actually saying they are equal. What is on the left is exactly equal to what is on the right. So using that concept, guys, we can even solve equations that are under exponents. Remember our topic, exponents. So these equations, since we're under exponents, will be called what? Exponential equations. All right? So these are exponential equations. A statement under exponents, giving us an equation to say one side is equal to another one. 3 to the exponent of x is equal to 27. The moment you have this, guys, the moment you have this, this is equal to this. It's an equation. But it is under what? Exponents because of this. 3 to the exponent of 2 to the exponent of y is equal to 8. X to the exponent of 3 is equal to 27. There is something about an exponent. There is something here, this one, that will tell you that you are under exponents. That will tell you that this is a different equation from this one that I used to have, which is given 2x is equal to 8. It's a linear equation. I do not have an exponent to say it is x squared or it is 2 to the exponent of x. No. It's just a basic equation. So these are examples of what? Exponential equation. They must be carrying an exponent. So how do we solve these types of equations? Actually, there are different types of questions. The first type of questions is when you are given, when given the unknown, when given the unknown on the exponent, when given the unknown as the exponent, or when we have it on the exponent as the what? As the exponent. This is the first condition that you have in these types of equations. So like I said, guys, if you are studying on this one of exponents, you feel like you're tired, please make sure that you leave. Then you just indicate the time where you finish so that you come back and finish from there. Because I'm going to cover everything like I said before. So this is how questions are given. When you have an unknown on the exponent, it is just like 3 to the exponent of x is equal to 27. The unknown is x, the variable. When given the unknown, that is what? The variable, the one that you want to calculate, the letter to be calculated. So in this case, it is easier for us to write our bases in the simplest form so that we can equate. There's a statement here that states that if, I want you to note this, I want you to note this one, when given same basis, when given same basis, like for an example, if a is raised to the exponent of x is equal to a to the exponent of y, like this. We have a same base, which is the base of what? A, as long this here is the same, but raised to a certain exponent, guys. There is no way in our mathematics that these two can just be the same like this, these two. It means that automatically these exponents will be equal. So therefore, it means x must be equal to y. So this is our statement. Once you see the bases being equal, it means the exponents are also equal. So this is the secret, guys, or the part that you need to have. Make sure that these bases are the same base. Make sure they're the same. So you can have them in simplest form. If you want to have your bases in simplest form, guys, you can use your calculator. Let me show you something here. Let's say you're given a number. You can know the number, its exponent in simplest form. So this is how you use your calculator to see, to know like the simplest number, like this 27. Which exponent can be used on 27? You'd simply do this one on your calculator. 27 is equal to, okay? Then you do this one. You say 27 is equal to, then shift, you press fact. Shift, then you press fact. So look here, it is giving you the answer. 3 to the exponent of what? Of 3. So if I see this 27, I know it is what? 3 to the exponent of what? Of 3. Once I see this 27 is 3 to the exponent of what? Of 3. So you can have this in simplest form. Let's say there was, let's just pick 8. So you just say 8 is equal to, all right, then shift fact, this one, fact. So as you can see, it is 2 to the exponent of what? Of 3. It is giving you. So here you can simply know that your simplest number is what? Is 2. The simplest base that you have there is what? Is 2 raised to the exponent of 3. So you can use your calculator to know that, because you want to have what? The same base, remember. All right, you want to have the same base. So this is how you solve, guys. Okay, so let us quickly have our questions using this law. I've explained a lot, guys. I'm not supposed to solve. I'm not supposed to explain all this. All right, solve the following equations. Solve the following equations. Equations like this. They just say equations. You are the one who is supposed to know. You are the one who is supposed to know what type of equation is that. You are the one who is supposed to know. Okay, what type of equation is that? So, okay, let's consider number 1. 3 to the exponent of x is equal to 27. So that's an exponential equation. We are solving for x. So like I said, 27 in simplest form, as you can see, guys, 3 is already the simplest number. Remember, 3 is a prime number. 3 is a prime number, so it's already simplest. A prime number, you cannot use any other number to divide. You cannot use 2, you cannot use 4. It's just 3 on its own, 3 and 1. Remember, it's 3 and 1. So it's the simplest number, this one. Let's move on to 27. Can we write 27 in the base of 3? I mean, this one, in the base of 3. Yes, it is 3 to the exponent of 3 in the base of 3. So if you have forgotten your exponents, like, guys, just try, use your calculator, all right? You know that you're in the base of 3. So you start 3 to the exponent of 1, 3 to the exponent of 2, 3 to the exponent of 0, until you get what? The 27. Or you can use that technique that I showed you of using shift effect. Once you see this, guys, once you see where you obtain the 27, write it like this. So as we can see, our bases are what? Are the same. There is 3 here. There is a 3 there. So what does it mean? Automatically, these exponents are equal. X is equal to y from this law. So therefore, we are saying what? X is equal to what? X is equal to this. X is equal to 3. Automatically, they will be equal because of these same bases. It only happens if you see those bases that they are the same. If they are not, guys, you cannot do that. All right. So that is why you have to change to make sure that those bases are the same. All right. Let's see this one. Let's say we are given, I'm just going to consider another question. Let's say we are given 3 to the exponent of x. 3 to the exponent of x minus 2 is equal to 1 over 9. All right, so for what? We are solving for x. We are still solving. So guys, look at this 3. It is already in what? Simplest form. So leave it like that. 3 to the exponent of x minus 2 is equal to what? 1 over 9. Remember, law number 6, which we said when x is raised to a, okay, I was using a there. Let me just maintain that. When a is raised to an exponent of negative m, it is same as 1 over a to the exponent of m. So guys, we can just do a vice versa, like to say it is 1 over 9. 1 over 9. So before, if it was 1 over this, 1 over this, guys, 1 over this, you see, 1, it is going to change to a negative. So let's see the exponent. So 1 over 9 is same as what? 1 over, in the base of 3, 9 is what? 9 is 3 to the exponent of 2. You can use your calculator, like I said before. So this is it now. 3 to the exponent of x minus 2 is equal to what? We use our law. So this one is a reverse from here to this side. 1 over this, it will carry a negative on the other side. So it will be 3 to the exponent of both. It's 1 over this. So it will be 3 to the exponent of what? Negative 2. The 2 will carry a negative. This M will carry a negative when you write it that side. So guys, these are laws. Laws, what is a law? The definition of a law. It is something that you must follow. That's a law. You don't use your own way, you follow that. So that is why, guys, I'm bringing these laws, because you are given, you must memorize your laws and know how to use these laws. From here to here, you can also do a vice versa. So exponents, guys, you must be very careful in your simplification. It's not that much. It's not even that much, guys. Do not even worry. Just do more questions. You're still on your level of revisions, so do as many questions as you can. So we are back now to that part where the bases are the same. As you can see here, there's a 3, here there's a 3. So what are we going to do? We equate our exponents. So we're going to take this exponent to this one. So we equate them. X minus 2 is equal to this exponent, which is what? Minus 2. So let us solve again. So we're going to have x. Okay, this is where we are, guys. What type of an equation do we have at this stage? What type of an equation? Forget about exponents now. Here you formed another type of an equation from our grade 8 mathematics. This is a linear equation. Remember those linear equations. How do you solve your linear equations? Okay, remember those linear equations. So we have to get rid of what? This minus 2 on the left-hand side. How can we get rid? It crosses the equal sign so that it will be a positive. Or I add to both sides so that this can cancel. So it will be x is equal to what? Minus 2 plus 2 is simply as 2 minus 2. That's a 0. Remember this part. So our x in this case was going to be a 0. Just like that. So guys, do as many questions as you can. Do as many questions. That's what I can just advise you. It is important to calculate every day. Mathematics is it's an everyday thing. You have to do a calculation almost every day so that you do not forget the concept that you'll be given. So that is it, guys. They were working with conditions. When you are given the unknown as the exponent, they can give you conditions where the unknown is on the base. They can do that. So when the unknown is on the base, sometimes you must figure out with the question. In most cases, like let's say we've got, they will give questions that you can even figure out. Like let's say we've got x to the exponent of 3 is equal to 27. These questions, guys, the law is simply the same. X to the exponent of 3. When it is equal, we must have same exponent here. So it means this must be 3 also. So we must have a number here raised to the exponent of 3. We must have same exponent. So it is just a matter of simplifying this in the simplest form. So meaning to say x to the exponent of 3 is equal to what? 27. Which number are you going to use? It is 3. Remember? In the base of 3, 27, we saw this one. So if you do not know, that's where you use your calculator. So it's 3 to the exponent of 3. So guys, in this case, it's like a reverse of what you've been doing. Remember, you're solving for x. So you can see that these powers, the exponents, I mean, these ones, they are the same. So it's a vice versa like what we had before. Automatically tells us what? The bases must be the same. There is no way that these exponents are the same. Then the bases are not the same. Just like what we had before. So therefore, automatically, our x must be what? Must be 3. So you must figure out that idea. Is it occurring or not? So that is it, guys. We're going to catch up with each other in next classes, working with question papers so that you see how these questions are being given. But for any other question which you seem to be of interest that you might need us to work on, guys, let us communicate. Also with my contact, guys, 0618644043, so that we can communicate. Send your question there on WhatsApp. Then I bring it on YouTube to explain that one. So you do not we're not going to work those questions on WhatsApp, guys. Bring them there, but I'm going to have the solution here on YouTube. So let us have as many question papers, share them so that I bring them. If you've got an activity, like let's say not an in-class activity, like that's an activity that you are working on as an individual. Guys, you are using smartphones, scan that activity, send to me so that I can see how to work out those questions. You have a question paper that you are having challenges, just scan that question paper as a PDF. Guys, you know these things, you're into technology. It's a world of technology now. So let's do that so that we send those PDFs, those pictures. If you have a challenge, just send them as pictures, clear pictures so that I can work on them back to you guys. So that is it, guys. Let us revise. It's almost time for our revisions. Very soon you shall be writing your term one activities. So make sure that you know all the topics. I gave you guys the ATP that you need for your term one, all the topics that you need in term one. Revise everything and also go through question papers. So that's it, guys. Till we meet again.